Hi Cougars! Today we are going to be looking at the properties of addition and subtraction and what makes expressions equivalent. So we're going to be looking at how things become equivalent. So by the end of today's lessons, you should be able to identify what an equivalent expression is, how to make an equivalent expression, and then you should be able to explain how multiplication and addition allow us to make equivalent expressions, because you can do something special with that. Okay, are you ready? So an equivalent expression. So equivalent expressions are sentences, right? So we know that expressions are math sentences. So equivalent means that it will have an equal sign. So one side is equal to the other side. And the reason why one side is set equal to the other side is because one side is the same as the other side. It could just be written a little bit differently, but they have the exact same value. So that means that they are expressions that have the same value, or math sentences that have the same value. So equivalent expressions are math sentences with an equal sign That's really important to know that they have an equal sign, because expressions don't typically have an equal sign. So if it's equivalent, then we know that we'll have an equal sign. Okay, so it will have an equal sign. So math sentences with an equal sign, and each side has the same value. All right, it just means that it could just be written just like slightly different. But they do, and they will have the exact same value. So we will have two different properties that we're looking at today. There's many different properties in math, but the two that we're going to look at today are the commutative property of addition and multiplication. So commutative of multiplication, commutative property of addition, and then the associative property of multiplication and the associative property of addition. And you have seen these properties both in elementary school. We're just going to now look at them and see how they work with algebra. All right, so first up, the first one that we are going to look at is the commutative. All right, the commutative property. So it just depends on if you are doing multiplication, then it's the commutative property of multiplication. If you are doing addition, it's the commutative property of addition. Pretty simple, right? Yeah. Just depends on which one you're doing. But what does that mean, Miss Englander? What are you talking about? All right, so commutative. I like to remember this property because of the word commute. It has the word commute in it. So think of driving, or like a morning commute. When people are driving to work, they are commuting. They are going from one place to another. And typically when you go from one place to another, you have to turn around and go back again, right? So think about work. Okay, people who go to work. They leave their house, they drive to work, and then when they're done with work, they turn around and they go the opposite direction. They leave work and then they go back home. They've commuted, right? So they've done the exact same thing. They've covered the same ground. They've just done it in reverse. So the commutative property is changing the order that you add or multiply an expression. Okay, so in addition and multiplication, you can move the numbers around the order, and it does not change. It doesn't change the outcome. Okay, it doesn't change the outcome of the answer that you get. That looks better. Sorry that it always gets so blurry. Okay, so the order, changing the order. Okay, let's think about you. On a typical day, right, when you go to school, you start at home, you go to school. When school is over, you turn around and you leave school and you go home. It doesn't change the amount of ground that you've covered. You've still traveled the same amount of miles typically, but you have done the same thing. Okay, so you've just done it in reverse. Commutative property, you're commuting. The numbers are commuting, the letters are commuting. It's just changing the order. Okay, so let's take a look at this. So if I were to do this to show you in numbers, where's my blue pen? Eek! Pen down, pen down. Okay, found it. It's okay, we found a pen. Okay, so if I were to write this in numbers as an example, with numbers, I could say 5 plus 8. Okay, so here it is with numbers in addition, or with addition. If I were to commute, or my 5 and my 8 were to commute, 5 plus 8 is the same as, so that equal sign means the same as 8 plus 5. I get the exact same answer on both sides. It doesn't matter the order in which I do it. I get the answer, okay? If I were to do the commutative property of multiplication with numbers, it would look like this. 5 times 8 is the same as 8 times 5. If you notice, the only thing that's changed is the order in which the numbers are written. Okay, so here's the commutative property of addition. Here's the commutative property of multiplication. All right, what if I did this with algebra? No, I'm scared. Don't do algebra. Yeah, we're doing algebra. All right. So if we did algebra, it would look like this. A plus B, you ready? Is the same as B plus A. It doesn't matter what A is or what B is because it's the same on both sides. They're even. This side of the equation is the same as this side of the equation. This expression is the same as this expression. These are equivalent expressions. Okay, this. A times B, this algebraic expression, is equivalent to this algebraic expression. Okay, they're the same. They're just being multiplied in a different order. We've commuted. They've commuted. Everybody's commuting. They're driving around. We wish we were commuting to school and to work, but we can't right now. If we were, this is what it would look like. Okay? All right. Whew. That was fun. Okay, I love commuting. Okay, here we go. Except when we get stuck in traffic. All right, associative. Associative. Watch how you abbreviate this word, please. Associative property. The associative property is the property that says you can change groupings. Okay, so you can change what you add in a group from one side to the other and get the same thing. Or you can change what you're multiplying in a group and get the same things. So essentially, associative property has parentheses. It has groups of things. It's a group. They're associated with each other. Groupings, okay? So you are changing the groupings. Changing the groupings. Of what is added or multiplied. All right, so what in the world does this mean? It means that the associative property tells us that when I move my parentheses around, it does not move the equal sign. It doesn't move the totals around, okay? It just moves what's being added. So in numbers, let's check it out in numbers. In numbers, the expression 7 plus 4 plus 2 tells us that I better add 7 plus 4 first, then add on 2. Is the same as adding 7 plus 4 plus 2 in parentheses. It doesn't matter because I am going to get the exact same outcome on both sides, right? 7 plus 4 is 11, plus 2 is 13. Okay, that's 13. Let's try over here. 4 plus 2 is 6. 6 plus 7 is, wait for it, 13. 13 is the same as 13. So the associative property of addition says it doesn't matter which group of numbers you add first, you're going to get the same answer on both sides. They're the same. They're equal. Okay, and that only works because they're all addition signs. So you can move your parentheses around. You can change your groupings and get the same answer. Okay, multiplication. If I had multiplication, if I said 7 times 4 times 2 is the same as 7 times 4 times 2. That means I'm going to get the exact same answer, okay? So when I look at this and when I solve, if I solve in the parentheses first, 8 times 7, that's the same as if I do 7 times 4 times 2. Both sides equal the exact same thing. They're equivalent. They're equivalent expressions. Okay, let's jump over here to this side. To algebra. Okay, algebra. Algebra. Okay. It's really fun to say it like that. You guys should try it sometime. Okay, in the world of algebra, it says that A plus B plus C is the same as A plus, oh my goodness. Where's my plus sign? It disappeared. Let's just make a really big plus sign. A plus B plus C. I moved my grouping symbols from the first set of letters to the second set of letters. Okay? It's the same. It doesn't matter if I add A plus B first or B plus C first. I'm going to get the same answer because it's all addition. Same thing with multiplication. If I multiply B times C, then times the A, I'm going to get the exact same thing as if I multiply A times B first, then times the C. It all gives me the same answer. And we're going to do some examples down below to show you in order what Miss Englander is talking about. Okay, so here we go. Let's do this thing. Are you ready? Let's do this. All right. So let's do example A. All right. Example A says 7 plus 12 plus X. It says what does it tell us it wants us to do? It says to write equivalent expressions. So I need to write equivalent expressions. All right, I'm writing equivalent expressions. So 7 plus 12 plus X is the same as, well, I'm going to look. This has parentheses. Up here I had parentheses, so associative property is all about groupings. So I know that this tells me I can move my parentheses. So I am going to move my parentheses and say 7 plus 12 is that plus X. Okay, I can actually simplify this even further. What is 7 plus 12? Well, 7 plus 12 is 19. So I can say that this expression, 7 plus 12 plus X, is the same as 19 plus X. This expression is the same as this expression. All I've done is simplified it down. So I use the associative property. I use the associative property and I moved my parentheses around, and then I simplified. And I got 19 plus X. Do not add the X into 19. I can't add the X into 19 because I don't have a value for X. The X must stand alone until we know what X is. We don't know, so we're going to leave it be. It's fine. It's done. Don't touch it. Nope. I said, no, don't touch it. Leave it. Just leave it right there. Don't touch that one. All right. No, I said don't touch it. Just leave it be. Okay, here we go. Here's example B. All right. I have I don't really like that example. Let me get a different one. Okay, so I have this example here. 10 plus A plus 9 equals, now that A and that 9 look the exact same. So let's make this look like a different type of A. There we go. Okay, 10 plus A plus 9. Okay, I first have to use the commutative property. And because if I just move my parentheses around, all I am going to do is just put this A right where it stays. And I want to try to get my A either to the end or to the beginning. Usually we want it like towards the beginning. So I'm going to switch places with the A and the 10 because it says up above that I can commute my numbers around. So I am going to say A plus 10 plus 9. And then I'm going to move my parentheses. So those are the same. So I'm using the commutative property. Commutative property. I had to move my A around because my ultimate goal is to combine the A or the 10 and the 9. I want to get down to simplified. And it can't simplify if the A is right in the middle. Okay, now I'm going to leave the A alone, and I'm going to add on 10 plus 9. Oh my gosh, look at that. It gives me another 19. So this one is A plus 19. Then I simplify. All right, let's do a multiplication one. Let's continue writing expressions, and let's try one with multiplication. All right, so again, we are making equivalent expressions. That is our goal right now, equivalent expressions. Okay, so I have 5 times 11y, which is 5 times 11 times y, right? So let's rewrite that out because this is really weird. So let's rewrite this. 5 times 11 times y. Now let's move our parentheses. Our parentheses used to be around the 11 and the y, but I can't combine those two things because one is numbers and one is letters. That's like oil, that's like water. They don't go together. So we're going to multiply these two things because look, numbers and numbers. Oh my gosh, numbers can go with numbers. Imagine that, numbers to numbers. So 5 times 11 gives me 55. And now I'm just going to drop down my y. So all I've done here is said 55y. I've simplified. I use the associative property of multiplication. I use the associative property of multiplication, and then I simplified. So I've started to combine things that are the same. That's it. That's all I've done. Okay, it's time for a try it. I would like for you to do a try it, just one today, and then you are free to go on your merry, happy way. Okay, I would like for you to do... Oh, that's why. That was weird. Okay. Okay, I want you to do this one. 6 times, that's a 6 times b times 7. 6 times b times 7. All right, hit pause right now, otherwise you're going to hear me do the try it, and you don't want to hear this. So hit pause right now so that you don't have to hear what's about to happen until you're ready to hear what's happening. Okay, here it goes. All right, so I need to move this b around. So I'm going to move this b here. I'm going to move that 6 right there. And I'm just going to move that 7. 6b, 7. b6, 7. I am now going to multiply those. And I know that 6 times 7 is 42. B times 42. So I get b times 42. And usually we don't write multiplication problems like that. We usually write them as like this, 42b. We put the b in the back side. That's sort of funny. Okay. On the side over here, I would like for you to rate your understanding of where you are at right now with 1, how do you feel about knowing the properties, why we can move things around, and then 2, equivalent expressions. Where are you at with writing equivalent expressions? How are you feeling about those? All right. When you are done, you can head over and check out your practice work. Ask questions in the Google Meet. And as always, please make it a great day the Cougar way. Thank you for all your hard work today. Bye.